So this session, I'm going to talk about the whole graph thing. We have rigid motion and transformation. Okay, so we have rigid motion and transformation. So when we talk about rigid motion and transformation, practically with transformation, that's the general name. Okay, so with transformation, we are looking at changes. So if something is being transformed, it means that looking at that thing is undergoing some changes. So what changes is that thing undergoing? Now the changes is what gives birth to different kinds of transformation. So the changes can be with respect to reflection, and the changes can also be with respect to rotation, and the changes can also be with respect to translation, and the changes can also be with respect to enlargement. Then you have some which is special mapping. And the truth is that the first four are all going to give you some form of mappings, but the last one is a special form of mapping. So we'll look at that in a nutshell, or we'll look at that very soon. So when we say the shape is undergoing some transformation, it means that the shape, as I said, is undergoing some changes. So these changes, we can have it with respect to position. We can have these changes with respect to size. Then we can have these changes with respect to shape. So these are the three different types of changes that any shape will undergo, that is under transformation. So all of these five will undergo positional changes. So you see that we will draw the object. After I reflect it, the position of the object will change. Where the object is will no longer be there. The image will be at a different place. Then we rotate. When we rotate to, the position of the object will change. Translation, same. Enlargement, same. Special mapping, same. So all of these particular five different types of transformations, as I said, will all undergo what I term as positional change. It means that their positions change. Where the object is, that is not where the image will be. Their positions will change. And that is how it is. So we can also look at size. Changes with respect to size. If we say changes with respect to size, it means that there are some changes that the shape will undergo, which will change the size of the shape. So maybe when I talk about changes, it means that we are looking at two things. We are looking at image, then we'll look at the object. So the object is the original. Then after it has undergone some changes, whatever we get is the image. Okay. So the image is what we are looking at as the transformed object. So when the object has undergone the changes, whatever we will have is now called a word image. Okay. So, and I'm saying that these changes we are looking at, some are positional. It means that when you have the original shape, the changes that it will undergo is that wherever the original shape is, the image will not be there. So the image has undergone what we call a positional change. So if I have my graph like this, and this is where my object is, my image can be somewhere here. So in that case, we can say that the image or the object has undergone positional transformation. And I'm also saying that the size of the object may also change. So it means that with this type of changes, if you have the object, the image would have a different size. Is that okay? So if that happens, then we say that the object has also undergone the transformation in terms of size. Then we have the shape. Some of these 5 transformations will change the shape of the object. So I'll take them one by one. When I'm done with all of them, as for all of them, they will all undergo positional changes. But some will undergo the changes with respect to size and then with shape. So you tell me which of them will undergo the changes with respect to size, which of them will undergo the changes with respect to shape. So if some are not undergoing the changes with respect to size and shape, then we are going to call those ones rigid motion. So note the word rigid motion here. We are looking at transformations that has nothing to do with size and shape, which means that the image and the object will have the same size, and then the image and the object will have the same shape. Then we say that the transformation is rigid. So we call that particular one rigid motion. So you will tell which of them is rigid motion, which of them is not rigid motion. That is it. So now let's take them one by one. Reflection. Reflection. When we talk about reflection, what are we looking at? Reflection has to do with a flip. A flip. If you are flipping something, you flip it along a line. So every flip is along a line. So, and a very typical example of reflection here has to do with opening the pages of a book is reflection. Because if you are opening the pages of a book, you are flipping. Why will you say you are flipping? Because these openings that you are undertaking is along a line. You see that whatever page that you are turning over to, if you compare it to the old page, you see that there's a line that connects them, which is the spine of the book. So the spine of the book connects the pages of the book. So if that is the case, then we say there is what? Reflection. So reflection is a flip, 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 flip. So if this is the book, what I'm trying to explain, this is the book. You see that if I'm turning over, I turn over, you see 1 and 2. If I turn over, it was closed, and I open it, I have turned. If I turn, it means that I'm going to turn along this line where you have 1 at the left and then 2 at the right. Then we say that we have the object has undergone the flip. So it is a flip. So when it comes to reflection, what is key or crucial is what we call the axis of reflection, or it's called the mirror line. Mirror line or axis of reflection. We have the mirror line or axis of reflection. Mirror line or axis of reflection. This is the 2 key things. So the flip is along a line. So that line is called the axis of reflection or the mirror line. Okay. So if we have our normal graph, this is our normal graph. Okay. With our normal graph, we are likely to have the X and then the Y axis. the X and then the Y axis. That is our normal graph. So the X axis here is a line. So we can flip along the X axis. In that case, the X axis becomes the mirror line, or it becomes the axis of reflection. Then we can also flip along the Y-axis. So in that case, the Y-axis becomes the mirror line or the axis of reflection. Is that okay? So up until now, I've given you some two different types of axis of reflection. That's the X and then the Y-axis. Then we can also have points on the X-axis. If I'm calibrating my axis, I have that. Let me just use this once. I have 1, 2, 3. I have neck 1, neck 2, neck 3. I have 1, 2, 3, 4. I have neck 1. I have neck 2. I have neck 3. All of these are axes are on the X and then the Y axis. So if these are on the X or the Y axis, then I can also have a line like this passing through 2 on the X-axis. Can you see that? The line is passing through 2 on the X-axis. If a line is passing through any point on the X-axis, we call it the line X equal to the number on the X-axis. That is what? 2. So if I draw a line through this, how will I call that? A line through neck 3, how will I call that line? How will
X
I
is
call that
equal to
line?
-3.
Yes, X is equal to -3. Very good. If I draw a line through -2 on the Y-axis, how will I call that?
Y is equal to -2.
Okay, that's also good. Y is equal to -2. All right. All right. So now, please, let's exit and come back. Please do exit and come back. Exit and then join the next minute.